Hi, my name is Ye. I'm from Google Research. I'm going to talk about the CVSS corpus, which is massively multilingual speech-to-speech translation corpus. And the speech-to-speech translation models we build on this corpus. So I'm going to talk about the background on speech-to-speech translation, then how we construct the CVSS corpus, and then I'll do a comparison among public speech-to-speech translation corpus. And finally, I'm going to cover the baseline models we built on CVSS, including cascade speech-to-speech translation models and the end-to-end direct speech-to-speech translation models. So let's start from background. So speech-to-speech translation is important for the communication among people speaking different languages. So people have been building such automatic speech-to-speech translation systems for decades. So conventionally, such systems is composed of multiple subsystems. For example, in the case of translating Spanish speech into English, the Spanish speech would first go through speech recognition system, or ASR, which transcribes Spanish speech into Spanish transcript. Then the Spanish transcript goes through MT, or machine translation system, to translate that into English text. And then the English text goes through a TTS system that finally synthesize English speech. And recently, there is a trend to fuse the ASR and MT into a single system, which is called direct speech-to-text translation model. As you can see, both approaches relies on text as the intermediate representation among systems. And more recently, there are a few works exploring speech-to-speech translation without relying on intermediate text representation. It's called direct speech-to-speech translation. There are two major approaches. The first one is end-to-end direct speech-to-speech translation. So there will be a single model that takes Spanish speech as input, and directly translate that into English speech. Another approach is based on quantized speech tokens as an intermediate representation. So there will be two models. The first model takes Spanish speech as input and translates that into a sequence of quantized speech tokens that corresponding to the target language. Then the second model that synthesizes the final English speech from the translated quantized speech tokens. Such quantized speech tokens typically come from quantized models like VKVE or Hubert. So as you can see, both approaches here does not rely on text as an intermediate representation. So compare the two major approaches. The direct speech-to-speech translation approach has a few potential advantages. First of all, because there's less cascading, so direct models is potentially faster and has lower latency than the conventional cascade models. Perhaps especially for the end-to-end approach. And finally, because the direct models works directly in the speech domain, so they're capable of preserving more speech information. So in humans communication, the information being exchanged is not only the content being spoken, but oftentimes the way you speak is more important, such as the emotion, the rhythm, the stress, the intonation, and also your voice. These are also important part of the communication. And thirdly, because there's less cascading, such model is also potentially has better translation quality by avoiding error compoundings. And last but not least, such models is capable of supporting languages without a written form. There are about 7,000 languages being spoken in the world today, and more than half of them have no written form. So this is an important piece. And on the other side, there is also a big disadvantage of such approach. To train direct speech-to-speech translation model, it requires parallel speech-to-speech translation training data, which is rare and very expensive to obtain. And that's also the reason that we are working on CVSS and release this dataset to the public. So next, I'm going to quickly talk about how we construct CVSS corpus. So CVSS corpus is derived from Corpus 2, which is a speech-to-text translation corpus. And Corpus 2 is further derived from the Mozilla Common Voice corpus, which is essentially ASR dataset. So, so the speech in CVSS is sourced from Common Voice corpus, which is crowdsourcing recordings or reading text. It's typically from Wikipedia kind of content. And the translation is done by professionals based on the source text. So what we do is we normalize the translation text, use an internal text normalization engine, and then we synthesize such normalized text into speech using state-of-the-art TTS systems. The dataset we created covers the translation from 21 languages into English. We synthesize two versions of translation speech. The first version is called CVSS. In this version, the translation speech is in a single canonical speaker's voice, which is natural, clean, and fluent. So this is a very high quality version of translation speech. The model trained on this version can potentially be used in a user-facing product. The second version is called CVST. In this version, the translation speech is in voices that are similar to the source speech. So this version can be used in the research on preserving speaker's voice during speech-to-speech translation. So I'm going to quickly talk about TTS models used for synthesizing speech in CVSS, but I want to touch the details. So for CVSS, we use a PNG-NET model, which is current state-of-the-art TTS model. In our internal large-scale subjective evaluation, the speech synthesized from PNG-NET got parity compared to studio recordings from professional actors or actresses. So that's a really high-quality TTS model. For CVST, we extended PNG-NET with zero-shot voice cloning capacity. We did so by adding a speaker encoder that was separately trained in a speaker verification task. So next, I'm going to do a quick comparison between CVSS and other public speech-to-speech translation corpus. So this table lists all the public speech-to-speech translation corpus available as of today. It includes two corpus that was released after CVSS, which is LibreS S2S and the LibreVox S2S. As you can see, the total number of available corpus as of today is very limited. There are a few key factors when we are designing a speech-to-speech translation corpus. The first one, of course, is what languages are covered and what are the amount of the recordings. So CVSS is among the largest ones in this table, with Vox Populi the only one being larger than CVSS. Another factor is the translation quality in the target speech. Typically, such speech can come from two different ways. One is from simultaneous interpretation. Another is based on professional translation. Because simultaneous interpretation is done by human in a very time and resource constrained manner, it's typically less comprehensive and less accurate than professional recordings. Though CVSS use the professional recordings, which have better translation quality. Another factor is the acoustic characteristics of the target speech. Is that noisy or clean? Is that fluent? Is that a single speaker recording or multi-speaker recordings? And is that a human recording or synthetic? This is important because the model needs to learn speech generation from such recordings. So typically, natural, clean, fluent speech is preferred. Single speaker recording and multi-speaker recording both have their own advantages, so this depends on the actual needs. But the single speaker recording is typically easier to model. It might feel less ideal to use synthetic speech as a training target, but if you take all those factors into consideration, synthetic speech may actually not be a bad choice. Because TTS model we used is of very high quality, the synthesized speech is oftentimes cleaner and more fluent than most of human recordings. And the synthesized quality is suitable to be used in a user-facing product. In CVST, the target speech is in a voice similar to the sound speech, so that this version is good to be used for research on preserving speaker's voice during speech translation. So we built baseline models on CVSS, including both cascade speech-to-speech translation, as well as end-to-end direct speech-to-speech translation. So for the category H, we built a speech-to-text translation model on Corpus 2, and then cascaded this model to the same TTS model as used for constructing CVSS. The ST model we built is based on conformal encoder and LSTM decoder. We use back augment as data mutation. The model we built outperformed the previous state-of-art trained on the same dataset by 77%. So it's a huge improvement on the translation quality. So the task baseline we built is very strong. We also built a two end-to-end direct speech-to-speech translation model using Translatotron and Translatotron architecture. So Translatotron is a synthesis model that the encoder takes source speech and input, and decoder directly generates speech in the target language. And Translatotron decompose the decoder in the original Translatotron into a linguistic decoder and acoustic synthesizer, and achieve better quality by this model architecture. So here are the results. The numbers showed here is the average blue scores on 21 X2 English translation directions in CVSS. The numbers look small because most of the translation directions are low resource cases. In the high resource cases, the numbers are about 20. So the three bars on left are models trained from scratch in CVSS. As you can see, the casting model performed best, and the original Translatotron performed worst. There is a significant gap between casting model and the Translatotron, but this gap is not widely huge. And the two bars on the right shows when we pre-train the models in Corpus 2 corpus, then the quality gap between Translatotron and the casting model got significantly narrow with less than 1 blue score. So these results demonstrate the effectiveness of both CVS corpus and the Translatotron end-to-end direct speech-to-speech translation model. Thank you for listening. The dataset can be downloaded from this GitHub repository. And if you have any questions, feel free to contact me. Thank you.